Let us study the methods used to prepare nanomaterials. The important methods are, the first one is top-down approach and bottom-up approach. And the second one is sol gel synthesis. Sol gel synthesis. Then third one is colloidal precipitation. Combustion techniques. Then hydrothermal techniques. Then the sixth one is high energy ball milling. Then co-precipitation. And the eighth one is sonochemistry. So the first method is top-down and bottom-up approach. And first of all, top-down approach. In top-down approach, the name itself says that the starting material having larger size, that is, it starts from bulk materials, and the breaking down of the larger entities will give nano-sized particles. So, in top-down method, larger entities are break down into nano-sized particles. This method has a wide application in technological and architectural industries because top-down method is used to produce the nano-sized technological devices. So nano-sized technological devices is prepared by using this method. And same way, architectural structures having micro scale is also produced by using this method. So architectural structures at a micro scale is also prepared by using this method. Top-down method is conducted by using the processes like evaporation and condensation, then laser pyrolysis, and ionic or electronic irradiations. Ionic or electronic irradiations. So these are the processes which are usually used to convert a bulk material into nano-sized particles. The important techniques coming under top-down approaches are electron beam lithography, then aerosol spray, Then high energy wet mill, high energy wet milling, etc. So electron beam lithography, aerosol spray, high energy wet milling, etc. Some examples of top-down approach techniques. The second one is bottom-up approach. In bottom-up approach, nanoparticles are built from molecular entities or atomic entities. So these molecular entities assemble themselves by the principle of molecular recognition. Molecular recognition in the sense it is a special type of interaction between the molecular entities by using non-covalent interactions such as hydrogen bonding, pi-pi interactions, etc. So by these interactions, these molecular entities assemble themselves and convert into nanoparticle scale. Actually, this approach is still under development. Some important techniques coming under bottom-up approach are sol gel electrode deposition, then colloidal precipitation, then organometallic chemical route, etc. The difference between the top-down and the bottom-up method can be pictorically represented as in top-down method, bulk material is powdered, then this powdered material converted into nanoparticles. While in bottom-up method, what happens is molecular entities assemble themselves to form clusters. These clusters converted into nanoparticles. The next method is sol gel synthesis. It is a low temperature, cost effective, highly controllable technique used for the preparation of high quality nanoparticles. So this is a low temperature, highly controllable, cost effective technique used for the preparation of high quality nanoparticles. It is a wet chemical technique. So this technique, sol gel synthesis, is also known as chemical solution deposition. Actually, the process involved in sol gel synthesis is the conversion of a sol or a solution into gel. So in sol gel synthesis, a monophasic sol or solution is converted into diphasic gel, that is containing a liquid phase and a solid phase. That is why it is called a diphasic system. So many methods are used to convert sol into gel. The simplest methods are, one is sedimentation, and the next one is centrifugation. These two are the simple methods which helps for sol gel synthesis. So what we have to do during sedimentation is just we have to kept it for some time to settle down. So after settle down, we have to pour off the excess liquid present in the system. That's all what we have to do during sedimentation process. Then during centrifugation, so centrifugation accelerate the phase separation. So that is why centrifugation is considered as a simplest method for sol gel synthesis. Even after sedimentation and the centrifugation, a little bit solvent will remain in the substance. We have to remove the little bit solvent present in the system. So the technique which are usually used to remove the extra liquid present in it are, one, thermal treatment, and the next one is firing process. So these are the methods used to remove extra solvent. So from all this, it may be clear that during sol gel synthesis, the process occurs densification. So what happens during sol gel synthesis is densification. The appropriate temperature for densification is low temperature. That is why sol gel synthesis is a low temperature technique. So in some other methods, the precursor is dissolved in suitable solvent, then either it will be coated on the surface of metals by dip coating method or rotating coating methods, coated on the surface of metal, or it is dried and converted into gel. So these are the techniques usually used under sol gel synthesis process. So the processes occur during sol gel synthesis are either condensation of the solution and addition of polymers and conversion into gel. These are the two processes usually occur during gelation or sol gel synthesis process. The condensation is usually occurs in sedimentation and centrifugation method, and these method, addition of polymers and conversion into gel, is what happening here in this method. So this is all about sol gel synthesis.